Hi there, I hope you are doing fine. This is Philip Koma, excellent tutor. So in this video, we're looking at linear programming paper 1. Okay, it comes in both paper 1 and paper 2, but what I'm going to teach in this tutorial video comes in paper 1. Okay, so when you're looking at linear programming, you'll be dealing with inequalities. Okay, inequalities, and these are the inequality signs that you need to know. So we've got less than, we've got greater than, we've got less or equal to, we've got great or equal to. Okay, yeah, so these are the four inequality signs that you need to know. Now when we're dealing with inequality lines, note that we're going to come across dotted lines or solid lines. Okay, these are the two types of lines that we are going to come across as we are dealing with inequality lines: dotted lines, solid lines. So if a line is dotted, these are the two inequality signs that you use. And if a line is a solid line, these are the two inequality signs that you're going to use. Okay, so yeah, this is just the introduction. Now we'll be dealing with finding the equation of a straight line, of which by now I know that you know how to find the equation of a straight line. So there are two formulas that you can use as you are trying to find the equation of a straight line. So you can use the first formula or the second formula. Any can work. Okay, but for this tutorial video I'll be using the second formula, but even the first one can work. So these are the two formulas that you use when you're finding the equation of a straight line. Okay, so y stands for the y coordinate. In the first formula, this is y1, stands for the y coordinate, and then m stands for gradient, then x1 stands for the x coordinate. Likewise, in the second formula, y stands for the y coordinate, m stands for the gradient, x stands for the x coordinate, and c stands for the y-intercept, meaning a point at which a line is cutting the y-axis. Alright, now let's continue. So if you come across a line which is slanting in that direction and the region is below it, then this is the inequality sign that you use, which is less than or equal to. Now why are we using less than or equal to? Because remember, this is a solid line, and for solid lines we use either this one or this one. So if the region is below it, then you use less or equal to. Again, if we're looking at a slanting line but it is now slanting in this direction, it is the same symbol, less than or equal to, because the region, it is still below this line. But if our region, or the region that we're trying to solve for, is above the line, then you use greater or equal to. It is still greater or equal to because the line is still solid. Even in this case, the line is now slanting in this direction, but still the region is above it. So the inequality sign it will be greater than or equal to. But if the lines are dotted, we use less than, but the scenario is just the same. As you can see, the region is below it, the region is below it, it's below this line, it's below this line, so we're still using less than. In this case, the region is above, so it will be greater than. Even in this case, the region is above, greater than. Okay, so these are just this is just something you can come back to as you are solving. Otherwise, if you are sharp and you come across a line which is slanting in that direction and the region is down, you automatically know to say, oh, I am using less than. Okay, or I'm using less than or equal to. All right, let's quickly move into looking at an example, and then I think you will understand better with an example. So we've got this x or y plane, so this is definitely the y-axis. So we've got the y-axis and we've got the x-axis there. I hope you can see the pen that I'm using. Maybe I change. So this is the x, then this is the y. Okay, and then we are supposed to find the three inequalities that are defining this region. As you can see, this is a region which is formed by three lines. Okay, these two lines that you are seeing, this is just shading, meaning this side is shaded, this side is shaded, this side is also shaded, and then we are remaining with this space which is not shaded. This is the unshaded region. Okay, so we are supposed to find three inequalities that are defined in this unshaded region. What that means is there are three lines that are forming up this unshaded region. What are the three lines? We've got this line, we've got this line, and we've got this line. These are the three lines that are defining this unshaded region. So we're supposed to find them. So we're solving the equation of a straight line. That is why I gave you those formulas, the two formulas. So I'll start by finding the equation of a straight line for these two lines because these are the easiest. So if you come across a line which is straight, it is horizontal like this, it is cutting y, okay? If you come across any line, whether it's cutting at 6, it is cutting at 1, it's cutting at 4, it is cutting y, okay? In this case, this line is cutting the y-axis at what point? At point 1, okay? So at this point, the y-coordinate is 1. Therefore, the equation of this line is y is equal to 1. That is the equation. Y is equal to 1 because this line is cutting the y-axis at a point where y is equal to 1. So y is equal to 1. But this is not an inequality. This is an equation. So we have to now make it or convert it into an inequality. How do we do that? By changing this symbol. Now, how are we going to know the symbol to put here? We need to ask ourselves a question. All right, so if I look at this line, where is the unshaded part? The unshaded part is above this line, isn't it? It is above this line. So since the unshaded part is above this line, I am going to use greater. Why not greater than? Why not greater or equal to? Because the line is dotted. Remember, if the line is dotted, what do you use? You use less or great. Okay, less or great. So since the line is dotted, that simply means my inequality sign will be either less or great. But in this case, it will be great. Why? Because the unshaded part is above the line. Therefore, y is greater than 1. This is our first inequality. Two more to go. Which one is the other? Which one is the easiest? We've got this other line. This line is also easy to find. In this case, we're going to ask ourselves, this line is straight. It is vertical. It is vertical and it is cutting x at point 2. Therefore, this line, it is x is equal to 2. X is equal to 2. Now, is this the inequality? No, it is not the inequality. How are we going to make it the inequality? By converting this symbol into an inequality sign. Now, here's the thing. When you're dealing with the x-axis, it's either left or right. So if the region is on the right side, then you use greater than or equal to. But if the region is on the left side of the line, then you use less than or equal to. I will repeat. When you're dealing with the x-axis, in other words, when you're dealing with lines that are like this, that are vertical and they are cutting x at one point, okay, then you're going to consider left or right. So if the region is on the right side, then that is greater than or equal to. But if the region is on the left side, then it is less than or equal to. Those are the two inequality signs that you're going to use. In this case, when I stand on this inequality, or in this line, I mean, the region is on the right side, isn't it? Therefore, my inequality sign will be greater than or equal to. Why am I saying greater than or equal to? Because the line is solid. And if the line is solid, you use less than or equal to, greater than or equal to. Therefore, our inequality sign will be x is equal to greater than or equal to 2. Simple, right? Simple. We are done with two inequalities. Now we go to our final inequality. Now for this line, for lines that are slanting like this, lines that are slanting like that, they are quite special, because when you're finding the equation of these lines, you need to use the formula. For these ones, you don't need to use the formula. Okay, even if you use the formulas, you will still find the same thing. So there's no need for you to find the formulas. So if you come across a line which is horizontal and it is cutting y at a particular point, for example, if we had a line which was going to cut y at 6, then y was going to be equal to 6. That is the equation. Y is equal to 6. Likewise, if we had the line which is cutting x at 5 and it is vertical like that, we are going to say x is equal to 5. That is the equation. But when you're dealing with lines that are slanting like this, the way it is slanting in this direction, or if it was slanting in this direction, then you need to use the formula. So this is our third inequality. The formula is y is equal to mx plus c. Or you can use the other one, but I'm going to go for this one. Now, when you're dealing with this formula, you need to first find your gradient. You need to find the gradient. And for you to find the gradient, you need 2 points on this line. You need to identify 2 points on this line, then use those 2 points to find the gradient. So when you're looking at this line, go for the clear points, meaning the points that are clear. Okay, and those points are this one which is here and this point which is here. So this point, it is 0, 6. At this point, x is 0. No, x is 0. At this point, x is 0 and y is 6. And then at this point, x is 5 and y is 0. So this point, it is 5, 0. At this point, x is 5, but y is 0. At this point, x is 0, y is 6. So take note that x is 0, x is always 0 on the y-axis, and y is always 0 on the x-axis. So at this point, this point is 2, 0, y is still 0. At this point, this is 0, 1, x is 0. So on the y-axis, x is always 0. On the x-axis, y is always 0. In the format of a point, it is x, y. So this is 5, 0, 0, 6. So we need these 2 points to find the gradient. That is why I have identified 2 points. So our points are 0, 6, 5, 0. Formula for the gradient, y2 minus y1 over x2 minus x1. That is the formula for the gradient. So we're going to say m is equal to, this is my second point, this is my first point. So since this is my second point, the y, it will be y2, which is 0. Then y1, 6. Then x2, 5. x1, 0. M is equal to 0 minus 6, negative 6. 5 minus 0, 5. So this is our gradient. And if you've noticed, our gradient is a negative. So take note of this. Lines that are slanting like that, gradient is always negative. Always. So after you're done finding the gradient, you can now find C. So there are 2 steps. Find gradient, find C. So we found the gradient using 2 points on this line, and this is our gradient. Now we are supposed to find C using the gradient and any of the 2 points. So we have to select 1 point amongst the 2. So I'll go for this one. So since I'm using this point, then y is 0, x is 5. And then I can solve for C. So I'm going to say y, it is what? 0. And then gradient, I found negative 6 over 5. And then x, it is 5 plus C. So I'm going to say 0 is equal to negative 6 times 5, negative 30 over 5 plus C. So 5 into negative 30, that is going to give me what? It will give me negative C. I mean, it will give me negative 6. So it will be 0 is equal to negative 6 plus C. And then this negative 6 will come this side. It becomes positive C. Therefore, this is our C. Remember, I said C is the y-intercept, and the y-intercept is a point at which the line is cutting the y-axis. So this line, it is cutting y at what? 6. That is why our C is 6. Okay, so if you are sharp, my excellent student, you can find the gradient. When you're done finding the gradient, if you have C, if you can see where the line is cutting the y-axis, that is your C. You can just go straight ahead and substitute where the C with the number which is there and the gradient that you found. Okay, so in this case, our gradient is -6/5. So I'm going to replace where there's M with the gradient that we found, and where there's C with the y-intercept, the number we found. But where there's y and x, I won't replace with anything. I'll just leave it like that. So therefore, our equation of this line, it is y is equal to, what is the gradient? -6/5. And then what is our C? I mean, this is x. Remember the x, and then plus our C, 6. This is the equation of this line. But are we done? No. This is the equation. We now need to find the inequality. If you look at how this line is slanting, this can guide us. First of all, it is solid, right? Similar to this, isn't it? Therefore, this is going to be the inequality sign. So it will be y less than or equal to -6/5 x plus 6. We're done. So these are the three inequalities that we have. So we've got this one, which is for this one. We've got this one, which is for this one, and this one, which is for this one. Simple. Let us look at the last one, last example. Okay. So in this case, we've got how many lines? We've got 1, 2, 3, 4, and this is the region. So there are 4 lines which are defining this unshaded region. 4 lines, 1, 2, 3, 4. So we can start with the easier ones. What are the easier lines? This vertical one and this horizontal one. So let's start with the horizontal one. So this point, it is 1. I just couldn't write it here because it wasn't going to be clear. So this is 1. There's a 1 here. This y coordinate, it is 1. So this line is cutting y, the y-axis. Okay, this is x. So this line is cutting the y-axis at point 1. Therefore, our first inequality is y is equal to 1. But no, is this the inequality? No, it is an equation. So to make it an inequality, we need to change this symbol. We need to substitute it with an inequality sign. So when you look at this line, is it solid? Yes, it is solid. Is the region on the upper part or on the bottom part? It is on the upper part. Therefore, y is greater or equal to 1. Greater than or equal to 1. First inequality. Second inequality, it is this one, x. X is equal to what? 2. Is the region on the right or on the left? Because remember, when you're dealing with the x, it's either right or left. So is the region on the right or on the left? It is on the left. Is it dotted? Yes, it is dotted. Therefore, we're going to use less than. So it will be x less than 2. We're done with our second inequality. Simple. And then we can now go to these 2 inequalities. So remember, for these 2, you first need to find the gradient. Okay. So I'm going to start by solving for this one here. By the way, there's a point which is missing. Let me just look for a marker. There's a point which is missing here. It is supposed to be negative 3, and then this point here is supposed to be 5. Yeah, apologies for that. So we're going to start by solving for this line. You can start with any. So I've decided to start with this one. So since I'm starting with this line, I need to pick 2 points, because when you're solving the equation of this straight line, what you need to know is that you use this formula. Y is equal to mx plus c. So I need to find my gradient and c. I can easily find c by looking at the line, but do I have the number which is here? Because remember, c, it is a point at which this line is cutting the y-axis. But is there a number? No, there's no number. So I cannot just guess to say, oh, I think my spirit is telling me there's 3. No, you can't guess. You need to solve. Okay, so if you haven't been given the number here for C, you have to find it. Okay, but we cannot find C without finding the gradient. So our first step is to find the gradient. And how do we do that? By picking 2 points on this straight line. What are the 2 clear points that we have? We've got this one, which is -3, 0. Remember, on the x-axis, y is always 0. And then we've got this other point, which is here. This point, it is 2, 5. 2, 5. So we've got 2 clear points. 2 clear points. This is 2, okay, 2, 5. So I'm going to use these 2 clear points to find the gradient. So m is equal to y2 minus y1 over x2 minus x1. So I've got a point which is -3, 0 and 2, 5. So m is, what is y2? It is 5, y1, 0. x2, 2, x1, so minus x1, -3. So if you've noticed, the negative is already in the formula. Okay, it's already in the formula. And our x1 is also a negative. That is why I've done this. So m is 5. So 5 minus 0, it's 5. And then this is going to be 2 plus 3, which is going to be m is equal to 5 over 5. Then m is equal to 1. Now, if you've noticed, our gradient is a positive. So for lines that are slanting in that direction, gradient is always positive. So we found our gradient to be positive 1. After finding the gradient, we can now find C. By using the gradient we are from finding and any of the 2 points. So I'm going to use this point and this gradient in this equation. So since I'm using this point, meaning y, it is 5. X, it is 2. So where there is y, I'll put 5. Then what is my gradient? It is 1. What is x? It is 2. And then I can now find C. So plus C, like that. So it's going to be 5 equals 1 times 2. It is 2 plus, this is going to give me C. And then 5, this is going to come this side, minus 2 is equal to C. 5 minus 2, 3. So therefore, my C is 3. Meaning this point is actually 3, the number I said. But don't guess in an exam. My guess was just correct here. But in your case, don't guess. So C, it is 3. Therefore, we can now say we substitute where there's M and C, but not where there's Y and X. So we're going to say, therefore, the equation of this line, it is Y is equal to, what is my gradient? It is 1, which is the same as X, because we know there's an invisible 1, which is the gradient, plus 3. But are we done? No, we need to convert this into an inequality. So when we look at this line, is there anything similar? Let me look for that paper. It looks similar to which one? It looks similar to this one, right? This line, similar to this one. So meaning this is the inequality sign, because this line looks similar to this line. So meaning this is the inequality sign. So y is less than or equal to x plus 3. We're done. We're done. All right, let's look at this other line. So remember, we need to pick 2 points. So on this line, there are 3 clear points actually. There's this point, there's this point, and there's this point. This point is 2, 5, this point is 4, 0, this point is 0, 7. So I can use any amongst the 3, and I can use 2 amongst the 3 to find the gradient, because I first need to find the gradient. So this is our third inequality. So our fourth inequality now. Okay, so the formula y is equal to mx plus c. Okay, so which points am I going to use? So in my case, I have decided to use this point, which is 0, 7, and I've also decided to use this same point, which is 2, 5. I will still find the same thing if I was to use this point and this point. It's just the same thing. Okay, so since I've used this point, I'm going to say, okay, first step, find the gradient. So m is equal to y2 minus y1 over x 2 minus x1. Gradient is equals to y2, it is 5, y1 minus 7, x2 2, x1 0. Gradient is 5 minus 7, negative 2, and then over 2. Gradient is equals to negative 1. See, it is a negative because it's slanting like that. Do I have my c? Yes, it is here, 7. c is equal to 7. So there's no need for me to find, there's no need for me to solve because it is already given. C is 7. C is 7. So I can just say, okay, y is equal to what is the gradient? Negative 1. So which is the same as negative x, okay? Then what is c? Plus 7. But is this the inequality that we're looking for? No. This is an equation. We need to convert this. Does this line look familiar? Yes. This line looks like this one, like that. So meaning we're going to go for this inequality sign. So therefore, y is less or equal to negative x plus 7. That is our fourth inequality sign. So yeah, that is how you solve these inequalities. It's very simple. All you have to do is practice. I'll send some questions that you're going to do. Make sure that you practice because this is easy and it comes in paper 1. All right, stay blessed.